In the name of Almighty God, the most compassionate and the most merciful, I welcome. And I would like to say, I welcome you all, my dear lovely brothers and sisters, to your own channel. By the way, today is our 5th lecture on trigonometric ratios. And in this lecture, we will have the proofs of the finding the trigonometric ratios of some degrees, which are 0 degree, 30, 45, 60, and so 90. In previous lecture, we discussed on signs of the trigonometric ratios in 4 quadrants. And so we discussed on the relation between the positive degree and negative degree. I'm sure that you have got the previous lecture. By the way, try to find a place. Do not forward the video. Please listen. When I ended the lecture and when I come to end of the every board, then please pause the video and write what you like. Okay. First, write your topic, trigonometric ratios of 45 degree. In order to find the trigonometric ratios of 45 degree, first you have to pick up a triangle which is a right triangle. I mean, this angle is 90. Try to pick up a right triangle in which both sides are equal. This side is A, this side is A. And you know, if the sides are equal, then this angle with this angle, they are same. And it is, of course, 45. And this one is also 45. Why? 45 plus 45, it's 90. And 90 plus 90, this one is 180, which is the inner angle of the triangle. Now, in here, if this one is A, this one is A, this side is not A. It is maybe B or C, whatever. Suppose this is C. Am I right? Yes. Now, I have to find this side with the related with the A. I mean, in terms of A. So, you know by the theorem of the Pythagoras, which says that the A square with this square, this is equal to C square. According to Pythagoras theorem, you know that these two sides of the right angle, the squares or summation of the squares of these two sides, it's equal to the square of the what? Of the hypotenuse. Now, C square is equal A square, this is 2A square. Now, take root side of both of them, so it will be C root of 2A. Now, C is, in terms of A, it is root 2A. Am I right? Yes. Now, you know the opposite side for 45, you know the adjacent, and you know the hypotenuse. If you know the 3 sides of a right triangle, you are able to define the what? They are all trigonometric ratios. Now, I mean, sine of 45, this one is equal to opposite divided by hypotenuse. Opposite A divided by hypotenuse, which is C. And A is A. And you know C. C is root 2A. So, it's cancelled. We found that the sine of 45, it is 1 divided by root. Yes. Cosine. What is cosine? Adjacent, which is A, divided by hypotenuse, which is C. Now, A is A, C is root 2A. We can cancel this one, and 1 divided by root 2. Tangent of 45, opposite by adjacent. What is opposite? A. What is adjacent? A. and you can cancel this one, so it is 1. Cotangent of 45. This one is the reciprocal for the tangent. What is the reciprocal for 1? It is 1. And secant of 45. It is reciprocal for the cosine. I mean root 2 by 1, which is root 2. And cosec of 45. It is reciprocal for sine. So root 2 by 1, which is root 2. Now, in conclusion, we can say that sine of 45, which is 1 divided by root 2, is equal with the cosine. Cosine of 45. Am I right? Yes. And so, tangent of, and the result is 1 divided by root 2. Tangent of 45 is equal with the cotangent of 45, which is 1. And so, sec of 45 is equal to cosec of 45, which is root 2. I think you have got. Write it, please. Trigonometric ratios of 30 and 60. In order to find the trigonometric ratios of 30 degree and 60 degree, you have to consider an equilateral triangle. Now, what is equilateral triangle? You know that all sides, they are equal. This side is A, this side is A, and this side is A. If the sides are equal, so the angles must be equal. This is 60, this is also 60 degree, and this one is also 60 degree. It is called equilateral triangle. Am I right? Yes. Now, but you know that if you want to define the trigonometric ratios, we have mentioned and discussed in the first lecture, or maybe in the second lecture, that the trigonometric ratios can be defined in a right angle triangle, not in else, or maybe that it one is equilateral or whatever. We cannot define. You have to pick up a right angle triangle. For this result, I will draw a perpendicular line on this side, which is called H, and this one is perpendicular to the A side. Now, in a equilateral triangle, you know that this perpendicular line, it divides this side into half and half, and also it divides and separates this angle into two halves. What do I mean? This side is A. Now it divides or separates this A into two half parts. It is A divided by 2, and this one is A divided by 2. And also this angle is 30, and this angle is also 30. Have you got? Yes. Now, if this triangle is made like this one, this is called A, this one is A divided by 2, this one side it's H, and this is 60 degree, this one is 30 degree, and it is a right triangle. Am I right? Yes. Now, in here, if this side is 20, this is 10. Why? Because it's A divided by 2. If this one is 30, this is 15. If this one is 40, this is 20. But if I ask you, this one is 40, what this one is? It's not defined. Why? Because it is not related with the A. So, we will define our Pythagoras Theorem. What does it say? It says h square plus A divided by 2 square is equal to hypotenuse square. Now, solve this one for h. So h square is equal to a square. This plus, put this one to the right side, it would be a square divided by 4. Now h square, this one is 4. 4a square minus a square, you know, h square is equal 4a square minus a square is 3a square divided by 4. Now take both side root, so it would be h and root 3a divided by 2. Root 3, root of a square is a, root of 4 is 2. So this side is defined root 3a divided by 2. Am I right? Yes. Now you are able to define any of this angle, maybe 30 or maybe 60. What should I define? First, we will come to 60. Am I right? Or 30? Doesn't mind. If you want to define 30, this is your opposite side, this is your hypotenuse, and this one is your adjacent. If you want to define 60, this is your opposite side, this one is your hypotenuse, this one is your adjacent, and this one is your hypotenuse. So, come, we will define first 60. So, this one is not considered in here right now. Now, for 60, sine of 60 is equal opposite divided by what? Hypotenuse. Now, what's your opposite? This is h, I mean root 3a divided by 2. Am I right? Yes. Now, divided by hypotenuse, a. You can cancel this one, so it would be root 3 divided by 2. Cosine 60. Adjacent divided by hypotenuse. What's your adjacent? A divided by 2. What's your hypotenuse? A. This one is cancelled, so the remaining is 1 divided by 2. And tangent of 60, opposite, which is root a divided by 2 divided by adjacent a divided by 2. This is cancelled, we will have root 3. If you want to define cotangent of 60, it is reciprocal for this one, which is 1 divided by root 3. If you want to define sec or secant of 60 degree, now this one is the reciprocal for this one, which is 2 divided by 1, which is 2. And cosec of 60, this is reciprocal for this one. Am I right? Yes. 2 divided by root 3. Now, come to 30. Sine of 30. If you want to define the trigonometric ratios for 30 degree, this is 30 degree. Now, this one is your what? Opposite. This is adjacent, and this one is hypotenuse. So, do not consider 60. Now you are here. This is your opposite, this is adjacent, and this one is your hypotenuse. Now, sine 30, it is opposite divided by hypotenuse. What's opposite? A divided by 2. Hypotenuse, A. A with A is cancelled, 1 divided by 2. And cosine of 30, it's what? Adjacent. Root a divided by root 3a divided by 2 by hypotenuse a. This is cancelled, so you will have root 3 divided by 2. And we will have tangent of 30. What's tangent of 30? It is opposite divided by adjacent. What's opposite? A divided by 2, adjacent, root 3a divided by 2. It's cancelled. We have 1 divided by root 3. Am I right? And if you want to come to cotangent, this is the reciprocal for this one, which is root 3. Sec of 30 is reciprocal for this one, 2 divided by root 3. And cosec of 30 degree, it is the reciprocal for this one, which is 2. Now, in conclusion, we can say that what is sine 30? It is 1 divided by 2. What is cosine of 60? 1 divided by 2. It means sine 30 with cosine 60, they are equal, and it is 1 divided by 2. Now, cosine of 30. Cosine 30, it is root 3 divided by 2. What is sine 60? Root 3 divided by 2. It means they are same. Now, the next one, tangent of 30 degree. It is 1 divided by root 3. Cotangent of 60, 1 divided by root 3. They are same. And cotangent of 30, it is root 3. Tangent of 60, it's also root 3. It means sine of this one with cosine of this one, cosine of this one with the sine of 60, tangent with cotangent, cotangent with tangent, secant with cosec, and cosec with the secant. So secant of 30 secant of 30 with the cosec of 60, it's 2 divided by root 3, it's also same. And cosec of 30, which is 2, sec of 60, it's also. This is our conclusion. It means if you memorize 30 degree, then you are able to define 60 degree. Sine of this one with cosine of this one, and cosine of this one with the sine of this one. I think we have got. Write it, please. Trigonometric ratios of 0 degree and 90 degree. If you want to define the trigonometric ratios of 0 degree and 90 degree, you are not able to define these 2 degrees in a right triangle. Why? Because a right triangle, it should be 90. And we have a hypotenuse. And for this alpha, this is your opposite side, and this is your adjacent. Now, your alpha is not 0. It should be 0. If this one is 0, the angle would be like this one. Still, it's not 0. The angle should be much smaller. It's not 0. Now, for 0, this one should be touched with the first line. Now, if this one touches, where is hypotenuse? We don't know. Where is your opposite side? We don't know. Where is your adjacent? We don't know. Same for 90 degree. The alpha should increase. This one. If this one is increased, this is your opposite side. It should be more increased. Still, it's not 90. But if this one is 90, if alpha approaches 90, now we do not define any triangle. This is something else which is not triangle. Am I right or not? For this result, you are not able to define in a right triangle, since you have to define a triangle in a trigonometry circle. What do I mean? Suppose this one is what? Trigonometric circle. Now, this is x-axis and this one is y-axis. Now, we will have a triangle here. This is your right angle triangle, in which it's O, this one is A, and this one is B. This is your alpha, this is your hypotenuse, and hypotenuse is equal to radius, which is 1. What is a trigonometric circle? Trigonometric circle is the circle in which the radius is defined 1 unit. Am I right? Yes. For alpha, AB is opposite side. For alpha, AB is your what? Opposite side. This one is opposite side. OB, this one is your adjacent. And OA, which is equal to R, this one is 1, and this is what? Hypotenuse. Am I right? Yes. Now, your angle is not 0. First, your angle should be 0. If your angle makes 0, this alpha should decrease. Now, what's happening? In here, A moves to this side, and this is your B. B moves to this side. I mean to circumference. Now, what do you think? AB is getting smaller. AB decreased, but OB is increased. Now, if your angle is 0, for 0 angle, you know that A comes to x-axis. So this distance is getting 0. I mean, when alpha approaches 0 degree, what is happening? AB approaches 0. AB approaches 0. What about OB? OB, you know, this is OB, and B moves to circumference, which the line joining origin with the circumference, this works like a radius. Why? Because this one is the circle of this, the center of the circle, and this point is the circumference of the circle. So OB increased, and B approaches this side. I mean, OB approaches 1. Now, what about OA, which is adjacent, or R? This is your R adjacent, this is your R, this one is also R, this one is also R. So OA, which is what? OA, which is hypotenuse, it remains same, and that one is 1. Now you know the value of the opposite side, the value of the adjacent, and the hypotenuse. So you are able to define the trigonometric ratios for 0 degree. I mean, what is sine of 0? Sine of 0, this one is opposite divided by hypotenuse. What's your opposite? AB, which is 0, divided by hypotenuse. Hypotenuse is OA. OA is 1. 0 divided by 1, it is 0. Cosine of 0. Adjacent divided by hypotenuse. What is your adjacent? OB, and the value of OB, it's 1, divided by hypotenuse, which is OA, and OA is 1. 1 divided by 1, it's 1. Tangent of 0. Opposite divided by adjacent. Opposite AB, which is 0, by adjacent. Adjacent, which is OB, and this one is 1. 0 divided by 1, it is 0. Cotangent of 0. It is adjacent divided by opposite. What is your adjacent? OB, and OB is 1. Am I right? Divided by what? By opposite. What's your opposite? AB, and AB is 0. 1 divided by 0, infinity, which is not defined. And same for secant of 0. It is the reciprocal for this one. 1 divided by 1, which is 1. And cosec for 0, it is what? It is 1 divided by 0, which is infinity. And this one also we can say not defined. This is all the trigonometric ratios for the 0 degree. Now come to 90 degree. In 90 degree, alpha should be increased. I mean, this A should come to this side. Am I right? Yes. Now put A here. This is your A. Now your triangle is, I think, now this is your triangle. B moves to left side. Now for when alpha approaches 90 degree, what is happening? What is happening in here? AB, which is what? Opposite. This is AB, AB, AB. If I put A in here, B moves to the origin. If A is moving to 90 degree, you know alpha is getting larger. Am I right? Yes. Now if A moves here, your angle is 90. Now AB is increasing. A comes to circumference, B comes to center. The distance between center and the circumference, it is 1, which is radius. Am I right? Yes. What's happening on OB? OB, this one is your OB. OB, this is B. OB, and B comes to O, and distance between O and B is 0. What's happening on OA, which is hypotenuse? OA, listen, this is OA, this one is OA, this is A. OA, this is radius, and once again A with O, this is R, which is 1. There is no change on the value of OA, but AB and OB, we have changes in the value. And when alpha approaches 90 degree, AB approaches 1, OB approaches 0, and OA approaches or remains same. Now you are able, AB is what? Opposite. OB is what? Adjacent. And OA is your hypotenuse. You know all of these values. Now you are able to define the what? the trigonometric ratios for 90. So come here, sine of 90, it's what? It is opposite divided by hypotenuse. What's your opposite? AB. The value is 1. Am I right? Yes. Divided by hypotenuse. Hypotenuse is OA, which is 1. 1 divided by 1, 1. So sine of 90 is 1. Cosine of 90 degree. This is sine. Now come to cosine. Cosine. Adjacent divided by hypotenuse. Adjacent OB is 0. Alhamdulillah. And divided by hypotenuse, which is 1. 0 divided by 1, 0. Tangent of 90. Opposite divided by adjacent. What's your opposite? AB, which is 1. Adjacent is OB, which is 0. 1 divided by 0, it is infinity, which is not defined, we can say. And what is cotangent of 90? Reciprocal for this one, 0 divided by 1, which is 0. Sec of 90, it is reciprocal for this one, 1 divided by 0, which is infinity and not defined. And cosec of 90, it is the reciprocal for this one, 1 divided by 1, which is 1. These are the trigonometric ratios of the 0 and 90 degrees. In conclusion, we can say that sine of 0, which is 0, cosine of 90 is also 0. It means they are same. Sine of 0 with the cosine of 90, like 30 and 60. And cosine of 0 degree, it's equal to sine of 90. Both of them are 1. Sine of 90, which is 1, like this one. Tangent of 0 is equal to cotangent of 90. What's tangent of 0? 0. And cotangent of 90 is also 0. Am I right? Yes, it's degree. Now, cotangent of 0, it is same or equal to tangent of 90 degree, which is tangent of 90, infinity or not defined. Sec of 0 with the cosec of 90, which is, what's cosec of 90? 1. Sec of 0 is also 1. And same cosec of 0, it is same with the sec of 90. What is sec of 0? Sec of 0, it is 1. No, I'm sorry, cosec of 0. Cosec of 0 is equal to sec of 90. Cosec of 0 is infinity. Sec of 90 is also infinity. Or we can say not defined. This one is also not defined. I think you've got. Write it, please. By the way, if you forget the values of the trigonometric ratios, we have a shortcut in which you can define all the trigonometric ratios of 0 degree, 30, 45, 60 and 40 and 90. What that one is, just draw a root of 0 by 4, 1 divided by 4, 2 divided by 4, 3 divided by 4 and 4 divided by 4. In here, this one starts 0 degree, 30, 45, 60, 90. Also, once again, 0 degree, it is 30, 45, 60 and 90. Now, if you want to define the sine, start from left to right. If you want to define cosine, start from right to left. If you are able to define sine and cosine, you are able to define tangent, cotangent, or whatever. Suppose, for example, all the trigonometric ratios are trigonometric ratios for what? For 30 degree. Now, how we can do? This is your 30. Now, if you want to define sine, so it starts from left to right. Sine of 30 is equal root 1 by 4. Root of 1 is 1, root of 4 is 2. This is your sine. If you want to define cosine of 30, now start from where? From right to left. This is your 30. Root of 3 by 4. I think you have got. Now root of 3 is root 3, and root of 4, this one is what? 2. Now if you want to define tangent of 30, it is sine of 30 degree divided by cosine of 30 degree. What is the value of sine 30? It is 1 divided by 2. Divided by cosine of 30, root 3 divided by 2. This 2 is cancelled, 1 divided by root 3. Now, if you define tangent, you are able to define cotangent. Why? That is reciprocal for tangent. Sec is reciprocal for cosine, and cosec is reciprocal for sine. Suppose another example. For example, all trigonometric ratios for 90 degree. Now, what is sine 90? Starts from left to right. This is your 90. The value is 4 by 4 under root. Root 4 by 4. 4 with 4 is cancelled. Root of 1 is 1. And cosine of 90 starts from here. This is your 90. Your value is root of 0 divided by 4. Root of 0 divided by 4. Am I right? And root of 0 is 0. Root of 4 is 2. 0 divided by every number, it is 0. Now, tangent of 90. I think this one is sine 90 divided by cosine 90 degree. So sine 90 is 1, cosine 90 is 0. 1 divided by 0, it is infinity, which is not defined. I think you have got. Write it, please. Complementary angles. What complementary angle is? Complementary angles are those angles which the summations of the angles are 90. If the sum of two angles are 90 degree, it is called complementary angle. What do I mean? I mean, for example, suppose this is a right angle triangle. Now, in this one, this is 90. This angle is, for example, alpha. This one is beta. If alpha plus beta is 90 degree, we call beta is the complementary of alpha, or alpha is the complementary of beta. In trigonometry, the sine of this alpha is equal with the cosine of the complement of alpha. Sine of alpha is equal with the cosine of complement of the alpha. What is the complement of alpha? It is beta. So sine of alpha is equal with the cosine of beta if alpha and beta are 90 degree, the summations of them. What do I mean? For example, sine of 30 degree. What is the complement of this 30? It is 60. Why? 30 and 60, they are 90. So sine of 30 is equal with the cosine of 60. And we have proved. Listen to me. If I say sine of, for example, 0, what is the complement of the 0, it is 90. Now sine of this one is equal with the cosine of 90. Tangent of 0 is equal with the cotangent of 90. Cotangent of 0 with tangent of 90. Secant of 0 with the cosec of the 90. I mean, if we want to talk about 12 degree, for example, tangent of 12. Now, what is the complement of the 12? I think it is 28. Why? 28 plus 12, it is 90. So, tangent of 12 is equal with the cotangent of 28. For example, you're talking about 45. Now, tangent of 45. Now, what is the complement of 45? It is 45. Why? 45 with 45 is 90. So, tangent is equal with cotangent. Secant is equal to with cosec of 45. Sine of 45 is equal with the cosine of 45. And we have proved this one. We have proved for 0 degree. We have proved for 30 and 60. I think you have got. Now, maybe you will ask that how can we prove in a triangle? Yes, it's simple. Suppose I want to define cosine of alpha. Cosine of alpha. What this one is? Cosine of alpha is adjacent divided by hypotenuse. B divided by C. Now, what is the complement of the alpha? It is beta. So, I mentioned that cosine of this one is equal with sine of this one. Sine of beta. Now, what sine of beta is? Sine of beta is opposite divided by adjacent, B by C. They are equal. And one thing more that I can say, instead of beta, can I write 90 degree minus alpha? Yes, from this equation. So, a sine of, instead of beta, we can write 90 minus alpha, which this one is beta. And this one is equal with cosine of alpha. If we talk about cosine of 90 minus alpha, now it is equal with the sine. Sine is with cosine. Cosine of 90 minus alpha is equal with sine. And also tangent of 90 degree minus alpha is equal to cotangent of alpha. Cotangent of 90 degree minus alpha is equal to tangent of alpha. And secant of 90 minus alpha is equal with the cosec of alpha. And like this one, cosec of 90 degree minus alpha, this one is equal to sec of alpha. This is called the relation between the complementary angles. I mean, sine of 90 minus alpha, it's changed to cosine alpha, and they are equal. Why this one changed? Because we have proved here. Cosine of 90 minus alpha is equal to sine. Tangent of 90 minus alpha with the cotangent of alpha. I think you have got. If I want to write, suppose sine of 90 minus 3a. If 3a is an acute angle, first it should be, both of them should be acute angle. Now from this equation we can write that sine of 90 minus 3a, 3a is alpha, is equal to cosine of this alpha. Your alpha is 3a. I think you have got. Suppose, for example, tangent of 90 degree minus 2 beta divided by 3. If 2 beta divided by 3 is an acute angle. Now what this one is, tangent is equal, from this equation we can say that this is your alpha. This one, 2 beta divided by 3 is your alpha. Tangent of 90 minus alpha is equal to cotangent of alpha. Cotangent of alpha, your alpha is 2 beta divided by 3. I think you have got. Write it please. By the way, it was our 5th lecture on trigonometry ratios. See you soon. Goodbye. Allah Hafiz.